chapter 2 is... here. And let's open up that program. And let's get started with this. Maybe we can just read this stuff in. The only thing is we have to put dodgers.csv in the right, and we have to, I think we have to, so why don't you get this started? So you have to, install some packages, right, to get this started properly. And you have to put the CSV file in the right folder. So you can type get wd to find the right folder, and then put it in there. Dodgers. And then we have to install which packages? Car and lattice. Then I think you can run the code just by copying it and run it all the way down to all the way down to table, line 28. So this was the last thing that we did, and let's see, remember what our data set looks like. How can we view the data set? Can anybody remember how to do that? How can we view the data set conveniently? Somebody give me a way to do that? Just so we can remember what this looks like.
Type the name of the variable.
Type the name of the what?
Variable, Dodgers.
You could type that, then you're going to see the whole thing. Anything else? You could use head. Okay, try that. Try head and Dodgers. Okay, we can see it that way. Also try fix Dodgers, F-I-X. You can see it this way. Okay, so this is the data set that we currently have. Stretch it out a little bit. Okay, so you can see it that way. So how many variables do we have in this data set? Well, right, we have 12 variables. Okay, now, what did we do in the last command here, except for the before head? What did we do here? We said with Dodgers, so we're using the Dodger data set, data frame, and what did we do? What command did we run? The table command. So what does that do? What does that tell us? That's what we finished with. That's how we finished last class. Hello? What does it tell us?
This counts the variables.
Okay, so we put in, how many arguments do we put into this table function? 1, 2. There's 1 comma, so there's 2 variables, right? So let's try it again. We did this at the end of last class. Just try table, or sorry, with Dodgers table, and just the first variable, just bobblehead. So let's do that again, but just have the first variable. And what do we get when we do that? So what do we get? We get all, first of all, what kind of variable is bobblehead? Is it numeric or is it nominal? Is it numeric or non-numeric? It's not numeric, right? So what is it? If we go back and check fix again, if you don't remember, here's bobblehead. What is it? It's a yes/no variable. Okay? So, it's not numeric. So what does the table do? Table function do? It gives you all the different values that bobblehead can take. How many values are it? How many values can it take? Just 2. If it was numeric, that wouldn't be such a great situation, right? Because then how many values could it take? A lot, right? But when it's not numeric, there's only a limited number of values that it can take. Here there are 2. So it gives you the values that it can take, and then what else does it do? The name is not exactly suggestive of what it's doing, unfortunately. But what does it do? Maybe I think a better name would be count. Okay? Because what does it do? It counts how many yeses and how many nos there are. Okay? All right, now let's run the command that he ran, which was with 2 variables. This one. So what is this going to tell us? Before you run it, what's it going to tell us? The table command. It's going to split it, yeah. So it's going to give you every possible combination of the 2 variables that you're mentioning here, which are bobblehead and ordered day of the week. So I mean by that, you can have bobblehead yes, and you can have Monday, yes Tuesday, or yes Wednesday, yes Thursday, yes Friday, and so on, or no, and all of those. So it's going to give you every combination, but it's going to count. So as I said, it's probably a better name for this isn't table, but count. But for some reason they call it table. So, so let's run it. Okay? Everyone get it? So for example, what does this 0 mean? What does this 0 mean? Sorry? Okay, what is it counting, by the way? What is it counting? The number of records or the number of rows that are in this intersection. The intersection of Wednesday and yes. Right? So in other words, that are Wednesday yes games. So Wednesday yes means what? A game that had bobbleheads on Wednesdays. How many were there? 0. Okay, what does this 2 mean? It's counting the number of records that have what? That were where? That had yes and were Thursday. In other words, it had bobbleheads on Thursdays. How many games like that were there? 2. What happens if you sum up all of these numbers? What happens if you sum up all these numbers? You get the total number of games, right? The total number of records. Right? Yeah, hopefully that's true.
You don't get the total number of games, but you get the total number of no.
No, I think you get the total number of records. Let's see, how could we sum that up? Anybody can think of a way to sum this up? How do we do that? I'm not sure. What is this?
If it's 0 though, then it won't. Then that's a game that didn't have it, so it still won't exist, right?
Ah, no, it's, oh,
So like that, it's still a game.
No, I don't think so. 0 is not this is not a game. There were no games like this.
I thought it was just no that they didn't give out bobbleheads. Or it's just no games.
No, because then it would be, there's none here, there's 12 here.
Yeah.
Right, I think so, right? So, but how do we sum this up? Well, before we try and sum it up, what kind of object is this? I'm not really sure. Anybody guess what this is? What kind of object this is? What's the structure of this? Maybe it's a matrix. Right? Might be a matrix. How do we find out? We could, how about if we run this command and do this? Let's see if this works, I'm not sure. Call it xx equals, let's see what happens. No, doesn't like that.
We already summed it up in the previous code, right?
When?
The 70 and the 11.
Yeah, right, we can sum it up there. I mean the 70 and the 11, yeah, but you're just doing it in your head, right?
No, we did it before.
Oh, we did?
Command.
What command did we do?
We just without order there for the single one.
But wait, that gave us 70 and 11, right?
Yeah, that's all added up though, right?
Yeah, and then you added 70 and 11, right?
You mean,
I want to add it up.
Yeah.
I want to add up the whole thing. So I was thinking I'd put it all in a table called XX, but that doesn't work. Okay, so I think, try this. Maybe this might work. Try this. Try within instead of with. Or I'll try it. Let's see if it works. Nope, doesn't like it. Okay, so we have to do it by hand. So I have to do this. So I won't use the with statement at all. I will do it like this. Okay, do you see what I'm doing? I'm wrong. That's that's wrong. I have to put the table somewhere else. That's wrong. Sorry, that's completely wrong. I'm not thinking straight. How do I do this? What do I want to do? I want to do... Oh, sorry. I'm definitely not thinking straight there. Okay, this should work, right? I'm just getting the table and storing it in XX. Okay, that's pretty straightforward, right? I just didn't use the width. Right? Okay, now let's find out what kind of object this is. Oh, it's a table object. But it looks to me like, let's try sum. Okay, it worked. Because table object is like a vector, actually, I guess. It's a kind of a vector, just like a matrix. I think it's a form of a matrix, just like a special form of a matrix. So it's a matrix, and a matrix is a vector, and if you have a vector, let's try that. Okay, what's my vec? What's my vec? It's a vector, right? So let's try sum on that. Yeah. Okay, so you can use the sum function to sum up a vector. So, but table is really a matrix, but a matrix is really a vector. So I was able to just sum up the entries in table, and I get 81. Okay, not so great, but I just wanted to make that point. I just wanted to make the point that the sum of all these entries is what? Is the total number of records, right? Which is 81. Okay, now I wonder what would happen if we put in 3 variables here. So let's say, what were some of the variables we had again? Let's say we have month also, right? So what's going to happen? Before you do it, let's imagine you're going to write this function. You're writing the table function. How do you want it to display, or what do you want it to display if I type in this? Comma, month. What do you want it to do? Before we check it, let's try and figure out what we'd like it to do. Some of you are. Only half of my brain is awake, actually. I don't know why, but it's only half awake. I wonder if that's sort of, anyway. Okay, so now, what about if we have 3? What do we want it to do?
Split it down again.
Right, so we want to take every possible combination of month, day of the week, and bobblehead, and count each of those, right? So how many months are in our data set? Probably like starts in April and goes to like August or something like that, so because it's only baseball season. So April, May, June, July, August, say 5. I don't know if there's 5 or not, but let's suppose there were 5. So we said before there were 14 possible cases, right? And then we have, with each of those, we can have April, or we can have May, or we can have June, or we can have July, right? So it's 14 times 5, for example, which is what? 70, right? Or 70, 14 times 5 is 70, right? So there would be 70 possible entries, and then we'd count how many we're in each one of those possible entries, right? That makes sense? Now how are we going to display that? So here, it displayed it like this, yes, no, and this. But when we have a third variable, we need a third dimension, right? But we can't display things in 3 dimensions on this display, right? So we have to come up with another way that we want to display it. So how should we do it? What?
An array.
Yeah, an array, but yeah, I mean, you're saying in the same way that we would display an array. And how was that, or how should we do it? Split them up, like we call it layers, maybe. So we could have one. We might have, since it's month, we might have 5 different layers. Yeah, 5 months. April, May, June, July, 5 months. Okay, so we might have 5 different layers, but I'm not sure it's going to work like that, because maybe if month came first, it would do it like that, or maybe if month comes last. I'm not sure. Okay, so let's see how it does do it. Okay, yeah, so it does different, so it has a different layer for, so with April, we have these. With August, I don't know why it does August next, but I guess that's the data set look like that, maybe. With August, we have these. So, okay, so what does this 2 mean? What does that 2 mean?
Friday, April.
And Friday in April, what, there were,
No bubble.
there were 2 games with no bobbleheads. Right. Okay? Does everyone get this idea? All right. What can we use this for? Why would we do this? I don't know. Anybody? Why would we do this? Let's put our brains together.
I guess if like you had thousands of lines of data, it would make it easier to look at. Rather than looking through like an Excel sheet.
But I mean, okay, yeah, that's right. Right, right. And what real question might we get from this? What real information could we get from this particular, about the baseball game? So first of all, just in terms of the spreadsheet, it would make it, I don't know, kind of extracting some kind of information from it. So we could say we're getting information by doing this. Because usually in data science or data mining, they say when you just have numbers, but no, you haven't gotten anything out of it yet, that's just data. Okay, but once you sort of organize it in some way, you're extracting some information. They call it information then. And then there's one more level they talk about, which is knowledge. And knowledge is like when you're finding relationships between one thing and another, and being able to predict one thing from another. They call that knowledge. Okay, but at this level, we could say we're extracting some information. But how could we use this particular kind of information? Anybody? We have a bunch of people here. How many brains do we have in this room? We have about 15 brains. So let's use the collection. It's like having 15 CPUs instead of just one. Right? So we have a little bit more power here. So anybody? Have any way we could use this? Like, for example, this number 2. How could we use that? I don't know.
You need to bring in like another factor. If you had attendees as well, then it would be okay.
Ah, right.
But right now, it's actually kind of useless.
Ah, okay, right. Right. We want attendees. Right.
Then you
Right,
could actually
right.
make some kind of comparison.
Ah, right. What kind of, like what? What could we do? How could we get attendees? Like, you're right, that's what we had over here, right? We had attendees, so we could like use that somehow to help us predict attendance. Here, I guess it's not so clear what we could do. Okay, all right, very good. Okay, let's keep going. So let's continue with the code that we have. So we did something like this up here when we created an ordered day of the week up here. Now he's creating an ordered month. So he's creating a new variable in the data set called ordered month. Okay? So let's do that. Just copy this code and create a new variable called ordered month. Okay? And this I think he's basically doing this for graphing purposes, like someone suggested last time. Okay, and then what's he do in the next line, line 39? What's he do on line 39? He makes ordered month into a factor. And why do we make things into factors? Because before it's a factor, it's just probably like a string. And I'm sorry, it's a bunch of strings. So just the point is that when you make something into a factor, you have a whole lot of functions you can use with it that you couldn't use if it wasn't a factor. Okay, so we don't see that yet. We don't see anything that we don't see why he's going to do it, but that's the reason. Okay, so let's make it into a factor. Okay? All right. Now, let's quickly review what we did last time here. So just refresh our memory. So we were talking about bobbleheads, and we want to know, is it financially worthwhile? What's the cost and what's the return? And the management question might be, will bobblehead promotions increase attendance? And will the increased revenues associated with tickets and concessions? By the way, what are concessions? By the way, anybody know what that means? Concessions. So not only are there ticket sales, but people are selling hot dogs and beer and Coke and things, and they also make money from that. Okay? Those are called concessions. And will the increased revenues associated with tickets and concessions cover the fixed and variable costs of putting on the promotion? Okay, so we use this data set. This is Dodger Stadium. The capacity is 56,000. We did some exploratory graphics. We saw days of the week here versus the attendance. We installed some additional packages. Okay, now let's go to here. So your boss asks you the following question. In the past, in terms of days of the week, how many times did we run the promotion and how many times did we not run it? So if he asks you that, what our code could give you this? So your boss wants to know, how many times did we run the promotion and how many times did we not run it in terms of days of the week? So what code would give that to you? The table code, the table function, right? That's the one we just did, right? So we'll answer that question for your boss, right? Okay, so it looks like this, right? We just did that. Okay, and what will that tell us? It tells us that. Okay, here we just did this. Now, here's one more thing here. What is this going to do? So with data equals Dodgers, so that's just saying that we're using the Dodgers data. So what are we doing here? We're plotting, right? We're going to make a graph. And what are the variables that we're plotting? Usually plot expects two variables, an x and a y variable. And usually they're separated by a comma. So here's the comma. So what are the two variables that we're plotting? Ordered month, so we're plotting the month, and the attendance. Okay, and we're going to do this. So let's see what we get when we do that. So you try it. And see what you get. Okay? So you get this picture, right? So you get attendance written here, you get month written here, you get the axis here is month, ordered months, and this is the attendance. Okay, so we have this exploratory graphics. Anything useful that we can understand by looking at these exploratory graphics? Anything useful we can get from this picture? Remember, this is a box chart, box chart. So which month has the highest attendance? Highest median attendance? June, right? That's this solid bar here. Tells you the median. So June has the best attendance. Okay, that's one thing we know. What else can we say? Which has the worst month? Which has the worst attendance? October. And what about the variability of attendance? What?
April, June has the most.
April and July have a lot of variability. Okay? Whereas June doesn't have that much variability. Okay, so this can be useful when you're making plans for what's going to happen in the game. Right, if you're running the game, this can be useful information. Okay, and the code for this was here. So what does it say? Plot this versus, what's this mean? What's the variable here? Attendance divided by 1,000. What does that do? That just scales the numbers, right? Just makes them a different scale. Okay? X label is what? The x-axis label is what? It's month. The y-axis label is what? Attendance per 1,000. The color is light blue for these box plots. And I forget what this stands for. Anybody know what that stands for? Anyway, it's something. Obviously, it's something.
I didn't even write that bit, it still works.
Yeah, okay. All right. Okay, now here's some more exploratory graphics. So in this chapter, we're basically working on learning about how to do exploratory graphics. In the next few chapters, we'll be doing more data modeling. But in this chapter, chapter 2 of this book, we're doing exploratory graphics, as you can tell. Okay, question. How does it, but we are going to do some regression in this chapter as well. Okay, anyway, still with the exploratory graphics, how does attendance vary over the season? That means over the different months, and not just the mean attendance, but what about the variation over the months? Oh, sorry, we already answered that. We did that already. Did that. What's happening? Where? Sorry, I did that already. Okay, all right. Let's think about some of the other variables we have and compare them to attendance. So what other variables do we have? We have temperature. So we might ask, how does temperature affect attendance? And think about how they could affect or relate to our main concern, attendance. We could think about how attendance varies with increasing temperature. And what code would give you that graph? So if you wanted to see that graph, what would you do? In fact, why don't you try it right now? See if you can get temperature versus attendance. So try and do that. Temperature versus attendance. What's the name of the temperature variable, by the way? Temp, T-E-M-P? Can't see it. Okay. Anybody else get this? Something similar to this? Oh, I know what LAS is. Let's try LAS equals something else. I forget what it stands for, but let's try that. No, I was wrong. I forget. I don't know what LAS is. We could find it out. We could look it up. Anyway, so what do we get here? This is temperature versus attendance. Does it tell us very much? Not too much. It doesn't look like there's exactly much of a relationship between temperature and attendance. What do I mean by there's not a big relationship between it? If I mean there's a relationship if I can say when temperature is low, I get a certain kind of attendance, and when temperature is high, I get a different attendance. So I guess you could say that when temperature is low, attendance is kind of low. Like when temperature is around 60, there's not very much attendance. But basically, it's not a great relationship, right? It's not like this. It would be interesting, I mean, it would be kind of interesting, yeah, if it looked like that, right? Then as temperature increases, attendance also increases. But it doesn't really look like that. Okay. So, going back to here. And, but it may be interesting to see how it does that based on other conditions. So, not just temperature versus attendance, but how about dividing it up also into cloudy or clear? Do we have a cloudy, clear variable in our data set? Was there a cloudy, clear variable? Yeah, there was. And also, does it, so this is kind of like in probability, we talk about conditional probability, which means, like, given that it's cloudy, what happens to attendance? Given that it's clear, what happens to attendance? But okay, let's just keep going. So the skies variable, I think, is cloudy versus clear. And we also have a day-night variable, which is also a binary variable, right? It's also binary. What are the two values for day-night? Obviously, day and night. Okay, and we have temperature. So how could we sort of put all this together and make a visualization? Now, obviously, if we put it all together, it's going to be kind of a complicated visualization. And when it's complicated, it means it's less easy to extract information from it. But still, we could try to do it, or he does that anyway, and we're going to follow along. Okay? And we're going to try and think about how this could affect or relate to our main concern, which is attendance. Okay, both skies and day-night are binary. Skies is either clear or cloudy, and day-night is day or night. So combining them, there are only 4 combinations, right? You can have, what? Clear and day, clear and night, cloudy and day, cloudy and night. Right, so there's 4 combinations there. So we have these 4 combinations, right? And then we also can do temperature along the x-axis and attendance along the y-axis. Okay, and what we're going to do is, this is one situation, this is another situation, this is another situation, there's another situation. We're going to have temperature here, and then temperature here, right? Because these are separate graphs, basically. We're just putting them all next to each other. And then temperature here, and temperature here, and attendance here, attendance here, okay? So we're going to do that. Okay? So let's see if we can visually discern any patterns in the games given these combination of conditions. And actually, we're going to throw in one more variable as well. And let's also include whether or not there's fireworks or not. So how are we going to view all of this in one picture? Well, we just saw we're going to use this to view all of this. And then I want to add in one more variable, like I said, which is whether there are fireworks or not. And we're going to use different shaped dots for fireworks versus no fireworks. Okay? So we're going to get this picture. Which, as I said, when we start including lots of different variables, I don't know, maybe for his brain, the author's brain, maybe this is useful, but for my limited brain, makes it kind of complicated to get information out of it. But I don't know, maybe you guys are good at this. So what can you see? Anything here? So again, first of all, what's the different shapes? We have a red triangle versus a black dot. What's that mean? Fireworks versus no fireworks? Okay. So any things you can get here? As I said, my brain is not so good at this, but I think other people's brains are better. So, use your brains.
There seems to be a lot more people that come on a clear night.
Clear. So you're saying the first column. He looked at the first column versus the second column and said what? There's more people on clear than cloudy. Okay, that's one observation. Good. Anything else?
There's also more fireworks displayed on a clear night.
Right. There are more fireworks displays on a clear night, but that, I guess they could actually call off the fireworks if it's rainy, right? Maybe they're supposed to have them, because you don't know, I mean, they must set this fireworks schedule, they must set it in advance, but maybe they actually call it off if it's rainy, right? So that you get more on a clear versus a cloudy night. Okay, that's good.
We don't know that.
We don't know what?
Whether they call them off or not.
Right, but why would it be like this? Why would you only have 3 on cloudy versus more on clear?
It'd just be a higher percentage of clear nights than cloudy nights.
Yeah, I guess so. Oh, right. Thank you. That's right. He said there could be more clear nights than cloudy nights. Right, that's good. Exactly. That's called a hidden variable. The number of clear nights versus, okay, anyway. Yeah, so anybody else? Somebody else give us some more things here? Observations? Yes?
There are more attendees from, if the temperature is from 90 to 80.
I'm sorry, if the temperature is between 80 to 90?
70 to around 80.
70 to 80, right. Most of the attendance is during days where there are temperatures between 70 and 80, right? Again, there could be a confounding, a hidden variable in there, meaning the actual number of days there were more. But yeah, anyway, still, the observation is correct. Anything else? Somebody else? A new person? Okay, anyway, so this gives us some information, right? So you might want to, there are actually 5 variables depicted here, right? Do you agree that there are 5 variables depicted here? What are the variables that are depicted here? This one is what? Temperature. This one is what? Attendance. This is what? Day is what? What was that called? Day-night. And clear is what? Sky's variable. That's already, we have 4. And then one more is what? Fireworks versus no fireworks. So we actually have 5 variables being depicted here, or we could say a 5-dimensional graph. Okay, if you want to make it sound fancy, right? Of course, the dimensions are not physically there, but we could say we have a 5-dimensional graph. Okay? Okay, now here's the code for that, starting here. So he uses a special package called lattice, which allows you to do this kind of graph. Okay, so here you can see, that you can import new packages into R, as we just did, and then if you know how to use them, you can create, you can do lots of extra stuff. So in this case, I guess the key function here is called XY plot, and that will generate this kind of fancy looking plot that we got. Okay, I'm not going to go too much into that code, but you can look at it yourself. Okay? Well, how much time do we have? What time is it now? 12:10. Okay, here's one more graph. Attendance by opponent. So he's again using the, I believe this is still using the lattice data. And we're going to get where he's going to use something called a BW plot. And I'll just show you the results since we don't have much time. So this is it. And here we have the opponents. And here we have the attendance. So, for example, the Braves, the attendance was generally not that high. In fact, there were only 2 games with the Braves. And the attendance was here and here. And on the other hand, like the Snakes, they had kind of high attendance. And some of the other teams also had high attendance. And we also have separated, we've also included a 3rd variable here. What's the 3rd variable? The first variable is attendance. Second variable is the team. And the 3rd variable is what? Day-night. Right? So we've separated it into that. And so maybe we can learn something from generating this picture as well. Okay? Okay, now we have to do one more thing, which we don't have time to do today. But now we get into the first real concept about data mining. And that is, we want to split our data set into what we call a training set. We're going to try and build a model. And in order to build the model and test it, we're going to take some of the data to build the model and the rest of the data to test it. So we have to do that. We have to split it. Okay, we have to learn how to do that, or we have to do that. And he goes through a fairly complicated process to get this done. Now, if you're using just data mining software, like Weka, you just do it just like that, just click a button and it's done. But But in R, you have to do it, you have to split stuff up. You have to take your, remember, what's our data set again? It's all the games, right? Each game is a record, so we want to separate some of those into what we call the training set of data, and the rest of them into the testing set. We're going to try and build a model for predicting attendance using the training set, and then we're going to see how well that model works by using that model on the other set of data, the testing set of data. Okay, so we'll come back to this next time, and I'll give you some homework in the meantime. Okay, that's all.